Okay, algebra students, we're going to look at section 10.8, chapter 10, section 8, systems of linear inequalities. And in order to do that, let's just do a little dusting of the cobwebs here and graph an inequality. In order to do that, we want to put it into that y with the relation symbol, y equals mx plus b form, but of course for an inequality. So we want to subtract x from both sides here. And we get 3y is greater than negative 1x plus 6. Of course, then we've got to divide everything by 3. It's a positive 3, so we can leave the relation symbol the same. And we get y is greater than 1/3 x plus 2. And so we're going to graph that. And that puts the y-intercept at 0, 2. And our slope being down 1 over 3. So I'm going to put a couple of points there and get a good line there. Because it is greater than, then that means that it should be a dotted line. So we have like a little dashed line going on. Since the points on that line will not be included, they're just a boundary. And because we're shading greater than, that means we are shading where the y's would be greater, which in this case is upward. So we're shading this portion of the graph. Now, in order to check, we like to check with 0, 0. So we can do our check. Now, 0, 0 falls into the place where it does not fall into the solutions. And so 0, 0 should give us a false statement. And so if we start with our original inequality, x plus 3y greater than 6, and we plug in 0, 0 there, we're going to get 0 is greater than 6, which is of course false, and so that's a good sign that we are shading in the right direction. So our first example for a system of inequalities, we want to graph the solution set of y is greater than 1 and x is less than 3. So we're going to graph both of those. So first we want to graph both inequalities. And we, of course, in that process will be shading each inequality. It is helpful if you shade using different colors. That's going to help. It's not completely necessary, but it's certainly going to help things out. If you don't happen to have another color, it's going to, you maybe want to shade with like a different pattern. So maybe, shading in one direction, lines in one direction for one, lines in another direction for another. But it's definitely helpful if you can do it with different colors. So we'll start with y is greater than 1. So that's going to, a y equal to line is just that reminder, hopefully remembering you've got Hoye Buck. So that y equal to line is a horizontal line. So we want a horizontal line at y is equal to 1. But it is a greater than line, so it is not included, so it should be dashed. So I'm going to give a dotted line there at y is equal to 1. And because it is greater than, we are going to shade upward of that line. So we're going to shade this region of the graph. Okay, and you can see I'm trying to do that lightly so that hopefully I'm going to find some intersection here. And then I want to graph the x is less than 3, and we should know that our x equal to line is a vertical line, and so at x equals 3, again, less than means it's not included, so that is another dotted line at x equals 3. then we are shading less than, for the x is less than 3, and so we're shading to the left. And so we're shading this region. And hopefully you can see where that overlap is. The shaded region that overlaps is your solution set. And so it is the overlapping region or the intersection of the shading that is the answer or the graph of the solution set. So the points that would fall within that green shaded region are the solutions to the systems of the inequality. So I'd like you to try graphing the next two inequalities on your own, and on Edpuzzle, decide what quadrant the intersection or the solving of the systems of that inequality occurs. And then once you answer that question, you restart the video and hopefully your solution will match mine. So y is less than or equal to -3, looks like that. We've got a horizontal line at -3, y equals -3. And because it is equal to, that line is a solid line. And because we're shading less than, we're shading downward on the y-axis. Y is greater than 2 is going to be a vertical line, or x is greater than 2 is going to be a vertical line at x is equal to 2. Because it's greater than, it should be a dashed line since it's not included. And because it's greater than, we're shading to the right, so you can see that in the pink. Then the intersection of those is going to be the area where those shadings cross. And so I'm just going to kind of go over that in purple. And that is the intersection. So hopefully you picked quadrant 4 for your area of intersection. Now it's not the whole quadrant, but it does occur in quadrant 4. Now, as you know, you're not always given inequalities in nice, neat forms, so sometimes we have to put them in a form where we can graph. So we've got that first inequality, y is less than or equal to x plus 3, and that one is ready to graph. We have a y-intercept at 0, 3. So I'll put that y-intercept at 0, 3. And our slope there is 1, so that means up 1 over 1. So I'm going to graph some possibilities, make it easier for me to do the line. Because that's or equal to, it will be a solid line. And then because it is less than or equal to, we're shading less on the y-axis. And so we should be shading the region going downward from that line. Now we want to graph the other inequality, but that one is not in a form that is ready to graph. We need to solve for y. So I'm going to solve that for y by subtracting 2x from both sides. And then I've got to divide everything by 3 to isolate that y. And I get y is greater than -2/3 x plus -2. And so then I can come over and graph that where I have a y-intercept of -2. And my slope is going to be down 2 over 3. And because that is a greater than, it is going to be a dashed line. And because it is greater than, we are going to shade upward on the y-axis. So that's shading in this area here. And hopefully you can see that the intersection area is going to be in here. So again, I'd like you to take your turn and attempt to find the overlapping between, or the overlap between these two inequalities. So solving the system by graphing. And on Edpuzzle, I'd like you to enter where your system solution occurs, and then we'll continue the video and hopefully your solution matches mine. So you can see for the first inequality that I have y is greater than or equal to negative 1/2 x plus 1/2. So my y-intercept is at 1/2, and my slope is down 1/2. Because it's an or equal to, the line is solid. And then because it is a greater than, I should be shading upward on the y-axis. For the second inequality, I get y is less than 1x plus -2, so y-intercept at -2, a slope of up 1/1, and because we're shading less than, we should be shading downward on the y-axis. And so we get an intersection area in between here where I'm shading in purple. Hopefully you answered quadrants 1 and 4 for your Edpuzzle question. If you still have questions about that or you're not getting to the right solutions on Edpuzzle, make sure you're bringing your questions into your algebra teacher. And we'll head on to the next one. So you may be asked whether or not an ordered pair is the solution to a system of linear inequalities. If an ordered pair is the solution, then it will make those inequalities true. So we're going to check both inequalities to see if that ordered pair makes the statements true. So the first inequality, we're plugging in the ordered pair -2, -1. So that would be -2 is greater than or equal to 1 minus 2 times -1. And that gives us -2 is greater than or equal to 1 plus 2. And so that's -2 is greater than or equal to 3. And that is false. So right away, that does not work in the first inequality. So the answer is no. Now, of course, if you would get a true for the first statement, you would want to check them both. But if you get a false, then it already doesn't work in that first inequality. And so it does not work as the system, because the solution to the system is the solution in both. So for the challenge, we're looking at determining the system of linear inequalities for the given graph. So that means we're trying to come up with the inequalities that make the graph true, or the intersection of the graph true. So we really just have to come up with the inequalities for the graph that's available. So I'm going to start with the graph here that I have in blue. Now, obviously, yours is not in blue if you just want to look at that corresponding one, or maybe you want to go over it in a blue colored pencil or a highlighter. And that, check out what would be the inequality of that line. Well, the line is solid and the blue shading is going downward. So I know that that has to be y is less than or equal to. And I have a y-intercept at 3, so that's going to be plus 3. And so I just now need to determine my slope. And if I look at that slope, I look at where it's intersecting, like cross points of the graph. Here is my y-intercept at 0, 3. And it looks like to get to the next intersection, I'm going up 2 and over 3. So that's going to give me a slope of 2/3. So there's that inequality. Then I want to take a look at the next one. So I'm going to look at the one in red or pink here on my picture. Again, I know that yours is in black and white, but we're looking at that shading, and you might want to go over it in a different color pencil or a different color highlighter. And now that inequality is a dashed line, and it's shading upward. So we know that that's going to be y is greater than. It is crossing the y-axis at -1. So that's going to give us a y-intercept of -1. And so again, it's just up to determining the slope. It looks like that slope is negative. It's going downward. So I'm going to look at the cross points on the graph. I've got a cross point here at -1. Looks like my next nice, neat cross point is down here. And so that's bringing me down 1, 2, 3, 4 across 1, 2, 3, 4, 5. So that is a slope of -4/5. And so I have my inequality. Your last job here for your homework is to complete challenge B and come up with the inequalities for challenge B. There are 3 of them, and you're looking for that area that we have shaded here that falls in between all of those inequalities. And you want to bring those questions in and that completed shaded portion to your algebra teacher, and we'll be checking that in class.